Continue with the part 2 of the forces in motion basics for PhET simulation. So let's check all those boxes here so we can have all the values in front of us. And then let's give it some friction, not too much, just a little bit of friction, maybe up to here, that's fine. And then I wanted to notice something. I wanted to notice that the force that we need to move this box at the beginning. Okay, so let's give it some force. Try to push it here. So the 1 Newton is still less than the static. You know, the box is not moving, so it's static. It's force of friction that is static. 9, 10, you see. Let's go up to 20 and let's stop at 20. Okay, and then let's see what are the forces applied on this box. If you recall, so we have the way down, and then we have the support or normal force up. So I took a screenshot and let me tell you exactly what do we have here. So we have the mass of the box, the forces acting on it is the way, which is mass times the acceleration to the gravity. It is here. See this, the acceleration to the gravity is usually toward the center of the earth. And then the way is usually down, perpendicular to the surface of contact. And this is the surface of contact between the box and the road. And then I explained it before, it's like the force between the particles of the two objects here, so between the road and the box. And okay, so you have opposite to way, we have the normal force that's opposite to it, exactly equal to the way. The direction is up, perpendicular to the surface of contact. Look, it is perpendicular. So if I move this, for example, if I move this arrow and I put it on the top of the mass of the way here, they will be the same exact dimension. So the normal force is the same exact value as the way. So if this is 490, then the normal force is 490. Okay, and then you have the force of friction. And then, as I said here before, so the normal force up, opposite to way, 90 degrees to the surface of contact. Then you have the force of friction. If it's at rest, then it is static and parallel to the surface of contact, opposite to motion. It is there actually, you see it. It is here. Okay, if you want to go to the other one, if I go to the other screen here, it is here. Opposite to motion because the guy is trying to push that way. And then parallel to the surface of contact. Look, it is going all the way parallel. Okay, so let's say that this is the maximum static frictional force. So from that, guys, what we can do, we can calculate the coefficient of static friction. Okay, say like the force of friction, the static one is 20. And then you have the coefficient of static friction. You have the normal force is 490. We already calculated that, 490 here. And then if you follow the calculation, you divide both sides by 490, so you have the coefficient of static friction. Okay. Now, as soon as the box moves, it's gonna be a kinetic friction. So let's try to make this box move. Let's put a little bit more force in there. And then I want you to notice how this number, I want you to focus to this number. And then you notice how this number is gonna all of a sudden drops when the box starts moving, and then you see a speed here somewhere, and then of course acceleration, and then the sum of the forces will change. So let's give it a little bit more. Oh, here we go, it is. See, all of a sudden it changed. It is now 16 newtons. Now the box is moving, so it is kinetic frictional force. And then look, there's a speed, there's an acceleration, and then here we have sum of the force, which is actually the 22 minus 16. So this is the net force 6. Okay, so we can calculate the coefficient of kinetic friction because now we know that the kinetic frictional force is 16. So we apply the same formula here. Well, it is 15. My calculation, I did it when it was 15, but I mean here when I did it before, I got 15. Okay. So the 15, and then you do the sum, so it is now 0.3. So notice now the coefficient of kinetic friction is less than the coefficient of static friction, because the static frictional force is more than the kinetic frictional force. Now, how do you calculate the acceleration? For the acceleration, you need to know that the net force, of course, equal mass times acceleration. So the mass, where am I? Sorry, hold on for a moment. Yeah, the mass, let me just pause for a second. The mass of the box is 50. The sum of the forces here is 6, so we can calculate the acceleration here. So 6, 50, and then you divide both sides by 50, so the acceleration 0.12 meter per second square. Is this the number that, yeah, it is here. It is the same thing. Again, one last thing, I just want to try it again. The thing that I want you to notice is that how the force, the applied force, or the change directly when the static frictional force or change directly when it becomes kinetic. All this time. So let's put some more here. Let's put this a little bit closer to our value. Here we're very close, 19, 18, 19, 20. Now any moment this number is gonna drop all this sudden, and then the extra force is gonna go to push the box, and then we have here a net force, and then you have an acceleration, you have a speed. So let's any moment now. Here we go, 17. So this is kinetic. Sum of the forces is 7. Acceleration is 0.14. That's all.